Hi, in this video I will give an overview concerning feed-forward neural network. In this video I will use a bunch of keywords, so I will briefly explain them. As we saw in previous video, KE equal the sum of WG key E minus 1 SGE minus 1 plus BKE minus 1 is the input value of the kth neuron of the layer E, and the output of the kth neuron of the eighth layer is SKE equal phi ke eke. Phi is the activation function, where bke minus 1 is a bias to the input value, which is considered as a determined threshold from which value the neural is significantly activated. In other words, the bias dictates behavior of a neural from the sum of the product of synaptic weight and output values of previous layer to activate or not. In a feed-forward network, the entry feed the first layer, the second feed the third, and so on, with no turning back. In a neural network, we also need an error function and an activation function. These functions are determined by the type of data processed. In this video, the activation function is phi ge on x equal the inverted 1 plus exponential minus x expect for the output layer, where the identity function is used. Thus, the output value is SGE equal phi ge ege equal the inverted 1 plus exponential minus ege for e different from r, and SGR equal EGR. And for the error function, we use the Euclidean distance between y and c, the half of it, equal the half of the sum from e equal 1 to m of y e minus c e squared, the half of the square of the Euclidean distance between the output of the neural network and the target, what is expected. So now we have all the definition to proceed so that we can perform predictions. Let's consider the UPLE XC we will use for propagation. The output value of the input layer are assigned to the x vector value, xg1 equal xg. The value are propagated through the neural network using the first and the second formula to give the output xg equal sgr. The output we compare to target cg using the third formula, which is the error function. At this stage, the mean of the error given by the error function E has to be minimized. The mean of E equal the inverted n, sum t equal 1 to e to n, et. T is the fifth error, n is the number of UPLE used to proceed, XC, and ET is the fifth error. So that was my brief overview concerning feed-forward neural network. To summarize, it's important to notice that in feed-forward neural network, the propagation is forward, so there's no turning back from the input we proceeded. But in this type of neural network, when we want to calculate the error, we do what we call back propagation. That I prefer to explain it in another video. Just let's focus on this one, on neural network feed-forward type. I hope I was brief and minimalist. Thank you, and God bless.